So, okay friends, good evening to all of you. So, today I am going to discuss about the aromaticity. This lecture is also the revision lectures. So, hopefully you will enjoy to this revision lecture. Okay. So, if you not subscribe my channel, so please subscribe my channel and click the bell icon so that you get easily notification when I upload my new videos. Okay. In my last lectures, I uploaded revision class of stereochemistry, which is basically based on the like 3D structures based chemistry, like determine the RS configuration and chirality, see the chirality and all those things I discuss, and homotopic, heterotopic and epimer anomers. So please, if you have not seen my lectures, so please go see. Okay, in this lecture I will discuss the aromaticity. So what is aromaticity? So aromaticity is basically gives the information about like something delocalization means planarity. If molecule or compound having aromaticity, then there will be own properties to follow the aromaticity condition. So if we talk about the aromaticities, so first compound's name came benzene. So benzene is the base points of aromaticity, because benzene is a most stable compound, and especially if this type of behavior found in any compounds, then we call the aromaticity. So basically benzene is very sweety smells, fragrant odor, okay, sweety smell. If benzene having other more functional group attached, like 1, 2, 3, 4, 5, 6, if any other ligand attached to any position, then the test will change, means it like order will change. So it depends on which functional group attached to the this benzene position. So this is the introduction parts, and we'll write also here like this. So both way we can present the benzene. Okay, so now I come to the properties. So what is properties of aromaticity? If compound is aromatic, then what will be the properties? Properties number 1, it should be planar with sp2 or sp hybridization. Okay, and properties number 2, it should be cyclic and conjugative system. And next property is it follow the Huckel rule, like 4n plus 2 pi. So electron, for checking this aromaticity, last one more point you should remember always, if the numbers of pi electron is odd, then surely you can say it is aromatic compound. Okay, so these 4 points you should remember when you search aromaticity properties of any compounds. So where n is any integer number like 0, 1, 2, 3, 4, like that. Okay, and if you see, and this type of compound is highly stable because of highly conjugations systems. That's why these types of compound, if any these properties is available on any compounds, then we can say that your compound is very highly stable. So we see energy diagram of this. This is E energy, and this is non-bonding, actually 6 numbers of atoms carbon. So here you draw six pi electrons positions. So here is 6 electrons, so first you fill 6 electron, and this is for bonding molecular orbital, this is for anti-bonding molecular orbital. Okay, So now I will take examples. So which type of examples follow the aromaticity? First I told you example first, which is very famous, benzene, which is highly aromatic. Second, and you also see here polarity and everything, cyclic conjugation. Huckel also follows 4 pi electron, means here 6 pi electrons, numbers of 3 pi. Here n is 3 pi electrons, you put 3, and one cyclic benzene, so you put 1 here for benzene case, so we will get 6 pi electron. So 6 pi is say even, so even pi electron, sorry, here is sorry. So here what is the statement is numbers of, if pi electron is odd, then we call the aromaticity. So here is the 3 pi electron, okay, 1 2 3 pi electrons, okay. And example 2, we took this example, cyclopropyl cation, this. So here is also 1 pi electrons, so this is also aromatic, 3. This example, this is also this is also aromatic, 4. This is also aromatic, and this example 5. This is also aromatic. 6 example, azulene, like this. Okay, this is also aromatic. This connect with like this, so this is azulene. This is also aromatic, 5 pi electrons, odd electrons. So this is all about the aromaticity. Okay, now I move the second, anti-aromaticity. What is anti-aromaticity? It is basically here some condition properties also similar with this aromatic, and this is highly unstable nature because due to delocalization of pi electron over the rings, and as a result increase electron energy, therefore stability goes down. So these types of compounds we can call highly or less stable than of non-aromatics. So some properties which are similar to be this. Here also polarity, it should be planar, cyclic and conjugated. Okay, and follow the 4 pi n electrons rules system. Okay, so this is basically not the pi electron, this is basically the numbers of pi bonds. If numbers of pi bond is odd, then we can say the aromatic. Here actually here 6 pi electrons. Okay, so numbers of pi bond 3, this is odd, that's why we call the aromatic. Here the numbers of pi bond 1, we call the aromatic. Here pi bonds is how much? 3, call the aromatic. Here is 2, here is also 3, call the aromatic. Okay, sorry for that. Here the numbers of pi bonds. Okay, so I am talking about the antiaromatic. So here you should remember point this. Here if numbers of pi bond is even, here the numbers of pi bond should be even. Okay, then we call the antiaromatic. Numbers of pi bond even, we should call the aromatic, sorry, antiaromatic. If we took the example, and this is highly unstable. Already I told you the reason why it is unstable, due to the delocalization of pi electron in the whole ring. Then energy will goes of pi electron energy that's why the stability will go down, decrease. This stability will decrease, that's why it is highly less stable. Now we took the examples. Okay, if you took the examples, see example like I am taking aniline type examples, like must have even numbers of carbons. Okay, even numbers of carbon, must have even numbers of carbon, like 4, 8, 10, like that. So here is aniline type. We took example aniline. So I took examples aniline. Like 4 members. This is UN bond. even double bonds, so we call the anti-aromatic. If we see for carbon, we see 8 carbon, like this is anti-aromatic, and these are also anti-aromatic. Okay, and because here the 2 pi electron, even pi electrons, so this is anti-aromatic. And more examples, if you took here okay, it is enough, and we can take other 8 numbers of carbon, 10 members of carbon aniline, that are also the anti-aromatic. Now I will come to the third. Third is non-aromatic. So what is non-aromatic? So non-aromatic is here the conditions are also similar with other tools. The structure should be cyclic but not conjugated. This is a different condition, and follow the Haeckel rule. It may or may not. Okay, may or may not surely say. Non-aromatic always follow the Haeckel rule. May not follow. Okay, so and here planarity is also absent planarity. Okay, so if you took the examples like this, this is anti-aromatic, non-aromatic, because here also the even numbers of pi electrons, and tau. If we took tau, this is also even numbers of pi electron but not planar. This is also not planar. So here the both are not planar, but these are the non-aromatics. Okay, so now we discuss the fourth homoaromatic. So what is homoaromatic? If you see this term, homo means partial, here these top of compounds having little bit aromatic natures. Okay, so this is homoaromatic. So here also some points contains one or more sp3 headaches, contains one or more sp3 hybridized carbon atom, okay, which in a conjugated cycle with conjugated cycle. Okay, and here is the condition about sp3 atoms. So here sp3 atom always lie in vertical above the plane. Okay, so you should remember these points, then you will solve the problem of aromatic system. Okay, so last point, which is earlier to like anti-aromatic and aromatic, similar properties, cyclic and conjugated should be cyclic and conjugated system. So if you take the examples, this so this is the sp3 carbon, and here is plus, and these are saturated atom, but what's about this sp3 carbon atom above the plane, lie in above the plane, and that's why it is homoaromatic. So all conditions are valid with these compounds. Okay, similarly if we take some other examples also, this so here so this is also sp3 above the plane, here the above the plane, and conjugated system. So this is also homoaromatic. Okay, so there are some more other examples you can see in books, read, then we will get more details about this aromaticity. So this is the whole things about the aromaticity, and if you discuss something little about craze, and if you took here example some other like this this is fused, okay, fused bond, and these are the so here's numbers of double bonds is present 7, so this is odd, so this is aromatic, okay. Now I see the order, so stability order, you see the stability order, holes what I have read like aromatic, antiaromatic, non-aromatic and homoaromatic. So order is most stable aromatic compound, then homoaromatic, then non-aromatic as I told, and last one antiaromatic, because I told antiaromatic is highly unstable due to the pi electron delocalization in hole over the ring, and due to the increase of the pi electron energy, so that decrease the stability of that compounds. So that's why the antiaromatic is highly unstable. So this is the order of stability, okay. Now I will give some information about crash. I'm not going detail, but will give some little bit information. So what is crash rules? So here the some condition for checking the crash rule says C2 axis will be present and even pi bonds, when even pi bonds is present, then we can call the non-aromatic. If odd pi bond is present, then we call the aromatic, okay. These two things I read in my previous aromatic and anti-aromatic places. So if you see examples, if you take these examples, this so here is C2 axis is present, so how much here is even numbers of pi bond is present. So if even numbers of bond present, sorry even, so it would become non-aromatic. C2 is not necessary. If C2 is present, then you can try this or this, okay. C2 is necessary for this type of compound, but it is not necessary even odd, but sorry, depends. If even is C2 is present in your compound and even numbers of pi electron, then we call it the non-aromatic. If odd numbers of pi electron present, pi bonds, then we call the aromatic. So if you to take these examples, this so here is also C2 present, C2 excess, but here if you see, then how much pi bonds is present here, 5. So if this odd numbers of pi bond present, then it will be the aromatic. Okay, so I hope you guys understood what I was trying to explain you. So okay, this is all about the aromaticity. If I get the time, so I will discuss in my next lecture little bit about the orthopara directing group, steric effect and electronic effects, and some substituent effect on alcoholic aromatic substitution. So in this chapter I will discuss the orthopara directing group, what is the roles of if your functional group is present ortho or and para and meta. So I will discuss in next lecture. So thank you, bye bye, good night.